Taking a look at a couple polynomial cases, finding inverses here, we'll start with this quadratic. Note that if you take a second and graph this, this is a parabola, it's shifted down 9 units. Not a very accurate graph here, but if we really think about this parabola, note that it fails the horizontal line test. So we can find this inverse, even though the algebra is all going to check out here, there's no guarantee that that inverse will be a function. So we are about to find an inverse that in this case is not a function. We don't have to worry about this just yet. We'll talk about the domain and range issues later. But just be aware that the algebra can check out and still you can be left with an equation that's not a function. So in order to do this, again, we're replacing f of x with y and then switching our x's and our y's. So switching our x's and our y's will give me that x equals y squared minus 9. So just like with the linear examples we looked at before, we want to get this y by itself. So the opposite of minus 9 is plus 9. X plus 9, those are not like terms. So x plus 9 is just x plus 9. And then to undo that square, we need a square root. So taking the square root of both sides, keep in mind when you take the square root of a number, square root of 16 for example, you get two answers, a positive 4 and a negative 4. Well, x plus 9 is just a number. Depending on what that value of x is, it'll be defined for some values of x and not others. But x plus 9 is just a number. So when we take a square root, we get both a positive and a negative case. So that gives us y is plus and minus the square root of x plus 9. This is our equation for the inverse. In order to get that into the inverse notation we want, keep in mind my original function is called f, then my inverse is going to be called f inverse. So f inverse will be plus and minus the square root of x plus 9. Again, a bit weird here because f inverse is not a function, so this f notation feels a bit hazy. But we'll really get into the domain and range issues later. Important to see the inverse operations. Note that I have a square root in the inverse and a square in the original. I have a plus 9 in the inverse and a minus 9 in the original. When you're finding inverse relations in this case, when you're finding inverses, you expect inverse operations. So it's always helpful to double check that it does make sense, that it looks like this function would undo that one. Jumping over to our cubic case here, we now have a polynomial where that exponent is a 3. Same process as before. To find that inverse, we want to switch f of x with y, and then switch our x and our y variables. So this is going to be x equals y plus 4, quantity cubed, minus 6. The goal is to get an equation where y equals some stuff. So to get y by itself here, well, we can add a 6. And once again, we have x plus a number. Those are not like terms. So x plus 6 is just x plus 6. Like the quadratic case, we want to get rid of an exponent. In the quadratic case, we took a square root to get rid of a square. Now that we're looking at a cubic case here, we're going to take a cube root to get rid of that cube. We do that to one side, we also have to do it to the other. So the inverse of a cubic function will be a cube root function. Hopefully that's not shocking. So we currently have the cube root of x plus 6, and that equals y plus 4. Last thing to do to get y by itself and finish this equation up, we can subtract that 4 from both sides. Be careful, we are not subtracting that 4 from the 6. The 6 is under the radical. So you can think about this as being its own term. This radical is separate from this whole number 4. So we're going to wind up with the cube root of x plus 6, and minus 4 is on the outside. Finishing this up and actually writing it in that inverse notation, note that this cube root, this is actually going to be a function, unlike the square root where we're kind of like, this isn't really a function, f inverse kind of gives us the heebie-jeebies. This one actually is a function. If you graph the original polynomial here, you will see that it passes the horizontal line test. So this one is going to work out great for us. Actually writing it in function notation will feel good. So f inverse of x is the cube root of x plus 6. And keep in mind that minus 4 is on the outside. Again, it's always helpful to double check. We were expecting a bunch of inverse operations because it's an inverse function. Well, I used to have a cube and now I have a cube root. Checks out. Used to have a minus 6 and now I have a plus 6. Checks out. Used to have a minus 4, used to have a plus 4. Also checks out. So what we're going to start looking at in the next section is now we have an inverse function and we have the original function. How can we double check that we did this process right? So we can use something called composition in order to put these two functions together and see that we actually did this process correctly. So stay tuned, that's what's coming up next.